Hello everyone and welcome back to our course. In this lecture, we're going to learn how to build an enemy controller with C++ for our first-person shooter game. So pop open your first-person shooter game, whether that's via the Epic Games launcher or just via your own file explorer. Open that Unreal project. Next, let's go into our content browser and go to the folder C++ classes. This stores all of the C++ files for our game. We have a first-person shooter character, first-person shooter game mode, first-person shooter HUD, and first-person shooter projectile. These were all built for us because we're using the first-person template. Let's go ahead and create our first new C++ class for this game. So I'm going to select the Add button here, and I'm going to choose New C++ Class. Here, we can then select a parent class. We're going to choose an actor. We want an object that can be placed or spawned in the world. Okay, then press Next, and let's give this actor a name. I'm going to call this our enemy controller. That is also going to be the name of our C++ and our header files. The class type can be public. All right, next up, let's hit Create Class, and that is going to pop open Visual Studio with our new class added. You want to make sure that if you had any previous instances of Visual Studio, you can get this message: the project first-person shooter has been modified outside the environment. Make sure to press Reload All. That is going to reload your project with that new file change, because now inside of Visual Studio we should see enemycontroller.cpp and enemycontroller.h. Okay, so there we go. All of that has been created, and they've also opened up. Inside of Unreal here, you should also see enemy controller now appear inside of your C++ classes project folder. If you don't see this, it means that likely it wasn't created properly or you didn't reload all. So you can try closing your project and reopening it to see if it comes back, or just recreate it again. Make sure when you're making a change to Unreal that you don't have anything in Visual Studio currently running, because that can sometimes cause the project not to save properly. All right, great. So we have enemy controller created. Let's go ahead and open that in Visual Studio. We have two files, the C++ file and the header file. We already have some default code created here because that will be generated whenever you create a C++ file from Unreal. We have some includes, which refer to some external files that we need to use in this file, because they have some properties or functions that we have to use in this file. We have our project name followed by API, and then we have this class created called enemy controller. You'll always have A being added to your class name. You'll notice it is a child of the actor class because we selected the parent class to be actor. Then we have a public constructor. We have a protected function, begin play, which is going to run when the play button is pressed or the game begins, or when an instance of this class is made, such as when an enemy object is spawned. And we're going to have multiple enemy objects spawned. We also have a public function tick, which is called every frame of the game. That is quite often. Typically games can run at 30 or 60 frames per second. We also have a C++ file. Note that it has to include its header partner here. Next, we have the actual implementation of, for example, the constructor. Here we have primary actor tick.b can ever tick equals true, because we want the tick function to be enabled. Then we have an implementation of begin play, just calls to the super begin play, which refers to its parent. The parent of an enemy controller is an actor. which is what we set. Then we have tick, which is the implementation of the function that's going to run every frame. You can put your own code into begin play and into tick and into the constructor, and that is what we will do in this project. All right, let's get started inside of enemy controller.h. Our first step is going to be to create our enemy. So let's go into public here and let's create a public property. So make sure you have this line indented once to make sure it's under the public section here. It's public, which means it can be accessed outside of this class, and I'm going to specify that this is a U property and that it can be edited anywhere. That is going to be the header of my property. Then I'm going to call this a U shape component type that I will call root box. All right, here we go. So now we can put to use this property. You may notice here we have this red underline, so let's just save and go to build and build solution in order to apply the changes that we just made, because sometimes changes can take some time to apply. If you get an access denied message in your output, it means you have to open up your project or your Visual Studio with administrator access. All right, so here we go. We now have the red underline gone because we built our project. It can take time for some new code to get updated and integrated into the project sometimes. So that's why we hit build in order to just speed up the process. This root box is going to refer to the box that is the enemy object. Next, let's create another U property. And again, it's going to have edit anywhere access. I'm going to make this a floating point number and I'm going to call it speed. Then let's set this to something like 100.0f. Feel free to have indents if you'd like. This is going to refer to how quickly the enemy can move because it's going to be chasing our player. Again, if you find that the code has not been integrated quickly enough, go to build and build the solution. That's going to just update your code to integrate with the existing code. Of course, that's not required because whenever you hit debug, that is going to compile your code. If you do get access denied, then reopen your project with administrator access. Next, let's declare a function that is going to run whenever the enemy collides with something or overlaps with something. So I'm going to declare a function. It will be void. And here I'm going to call it onOverlap. This is going to take in several parameters. First, a U primitive component. And this will be called the overlapped component. Next, an actor. And this will be called other actor, followed by a U primitive component that we'll call other component. So you can see some resemblance here to what we had with our projectile. We're also going to have an int 32, which we'll call our other body index, a boolean called b from sweep, and a const f hit result that we'll call our sweep result. So this is the setup for creating the onOverlap function. So make sure you have your code exactly as we do here. And if it doesn't compile in time, then just rebuild the solution in order for all of the little red lines underneath to be removed. They'll be removed as soon as the build completes. Let's just wait here for all the actions to process, and you'll also be told if you have any mistakes here. For example, here we have an unresolved external symbol. So let's see what we might be missing here. We have an AA actor, a U primitive component, an other body index, B from sweep, and F hit result, sweep result. Okay, there we go. Everything has been compiled because our red lines underneath have been removed. Okay, next you'll notice onOverlap has a green underline because we need to actually fill in the body of this function inside of the C++ file. For that, let's go into enemycontroller.cpp. Here we're going to enter our constructor, and first I'm going to take our root box, which comes from enemycontroller.h, and I'm going to create it using create default sub object. This will be a ubox component, and I want to give it the text of root. In order to be able to use the ubox component, we do have to include its originator, so where this comes from. We have to include that at the top of our file here. So I'm going to add here #include, and the box component comes from components/box component.h. All right, so now we will be able to use that ubox component. There we go. And also for this text, just don't forget that second parentheses there. Okay, great. So now we have defined our root box. Let's go ahead and enable overlapping events before we actually build out our onOverlap function. Next, I'm going to enable overlapping events. So I'm going to grab the root box and use set generate overlap events and pass that to equal true. And here it's a function, so I'm just passing in true as a parameter. Okay, there we go. Next up, let's also enable for dynamic overlapping. So let me just add a space here. And next, I'm going to grab the root box and call the function onComponentBeginOverlap. I'm going to call add dynamic. Then I'm going to pass in this, which is the enemy controller, followed by @ a enemy controller onOverlap, which is that function that we created. All right, so you can see onOverlap is a helper macro to bind the object instance and a function into a dynamic delegate. So this means when the root box begins an overlap, we're going to call onOverlap of the enemy controller. So our enemy controller is what's going to handle overlapping events. Next, let's go ahead and declare our onOverlap function. And it has to have the same parameters as in this enemy controller.h. So we can actually just copy that function. Let's go back to the C++ file and just paste it somewhere. Notice that it has to match what is inside of the header. Okay, but this time we're actually filling in the body of this function. As well, we have to specify where it comes from. It comes from a enemy controller. Okay, so we use the double colon here to specify that we're filling in the body of the function that was declared in the header file. So what should we do in here? Well, first, let's write an if statement to check when our enemy collides with another actor, such as the first-person player. When the enemy collides with that first-person player, we could end the game, or we could pause the game, or just reduce the enemy's health. Whatever we want to happen, we can also reduce the player's health. Whatever we want to happen when the enemy touches another actor, such as our player. So how do we check what was part of the overlap? Well, that is what all of these parameters are there for. That's why we have this overlapped component and the other actor and the other component. So I'm going to check if my other actor equals uGameplayStatics get player character of this world. So I'm going to grab the world by using get world and checking if its player is 0. To enable uGameplayStatics, we do have to include it at the top of our file. So I'm going to go to the top here and I'm going to include with #include kismet/gameplaystatics.h. Just make sure that the enemy controller is up top. This will allow us to use gameplay statics, which we need. And here we're going to get this message that there's a conflict between comparing the actors, because here we're comparing an actor to a character type. So first, let's go ahead and grab the character of this actor before we actually can put it to use and compare it to see if the other actor, which is what the enemy collided with, was the first person player. So here I am going to create a type A character, and I'm going to call this collided with because it's what character the enemy collided with. And I'm going to assign this to equal our actor cast to a character. So I'm going to take a character and I'm going to cast my other actor to the A character. That way I can now check what that other actor is. We're checking if the actor cast to a character that the enemy collided with or overlapped. We're checking if that is equal to the first player character in this world. Because here we're using get player character, which takes in a world and a player index. And if we have just one player, then 0 is that first player's index. If this passes as true, it means that our enemy collided with our first person shooter. So we can perform some action here, like we could reduce the player's health, or we could stop the game. Let's start by just pausing the game. To pause a game, we're going to call gameplay statics, and we're going to call the function setGamePaused. Here we're going to pass in get world and true, because we're pausing the current world. SetGamePaused takes in the world that you want to pause and a Boolean true or false value, be paused, which is short for Boolean paused. And it's basically saying, do we want to pause true or do we want to not pause false? Now let's save all of our edited files and let's hit debug to compile our code. This is also going to launch Unreal. Now, if we currently press play and test this out, we won't see our enemy appear yet because we actually need to add our enemy to the game. We need to add it manually via Unreal. So join me coming up in our next lecture where we're going to add our enemy to our Unreal project. So we will connect this C++ code to some actual object in our game. Hello everyone and welcome back to our course. In the previous lecture, we learned how to write C++ functionality so that whenever the enemy collided with our player, we wrote the functionality to pause our game. If we want to actually test out that functionality, we need a visual component to our enemy. Otherwise, if I press play, I'm just running around this game, but my enemy doesn't actually spawn. So let's actually create our enemy inside of the game as a visual component, and then we'll be able to see whenever we collide with that enemy, our game will pause. So close any debugging runs of your Visual Studio solution and just open up your Unreal project. Here we are going to add a visual component to our enemy controller. So we have here an enemy controller in our C++ classes folder. And we could just drag that right into our game, and we'll see if we press F, we can zoom in on this. It's just this invisible box. So let's make this a visible box instead. I'm going to go into the details window and add a box that we can actually see. I'm going to add a mesh. If you don't see the details window, go to Window and then select Details and open up a Details tab. Then here, I'm going to press the Add button in the top right-hand corner of the Details window to add a new component to this actor. Here, I'm going to select a cube. And now look at that. We can see our enemy looks like a cube. Let's change its material so that way it stands out from all of the other cubes, because this isn't just a cube, this is an enemy. So this cube has all of the C++ functionality that we wrote. I'm going to change its material in the Materials tab here. For example, let's see, we did enable starter content, so we'll have a lot of materials here, such as gold. If I give us a gold material, look at that. Now my enemy is differentiable. Okay, and I can press Control S or Control Shift S to save or save all. Okay, now I can press play and I will actually see my enemy inside of my world. I just have to rotate around and there it is. I can also hit my bullets off of it. You'll notice though, if I touch the enemy currently, the game doesn't pause. So there's one more thing we have to enable. We have to change how the collisions are being processed. So let's click on this enemy controller and I'm going to click on the cube object specifically. Okay, so not just the root box, which is the root of the enemy or the enemy itself, but actually on the cube mesh. That is the gold visual here. And I'm going to go to the collision tab here, the collision component. Here I'm going to change the collision presets. Instead of using block all dynamic, which is typically a default collision preset of a cube, I'm going to change this to no collision. That way the collision will be processed by my root box instead, which actually comes from my C++ file. So now I can test this out again. Okay, let me rotate around. I can still bounce my projectiles, but look, once I touch the cube, my whole game froze. That's exactly what I wanted. It didn't just freeze because of a crash. It actually froze because we set it in our C++ code to freeze or pause the game when the enemy collided with a player. We wrote that in our code and we compiled the code, so that's why we're seeing that now. So you'll notice as soon as I touch that cube, the game pauses and I can't move around anymore. I have to hit escape to stop the game. Later on, we can write functionality to actually allow the player to manually restart the game via the user interface of the game. All right, so what we had to do is give this instance of an enemy in our world a cube and also change its collision presets of the actual cube itself. So not of the enemy controller, that doesn't have collision. Well, it does have collision, but not the property we want. Root box here also has collision, but what we really want is the collision of the cube to be no collision. And that is how we can test out the functionality that we wrote in C++ in our game. And this proves that the code that we wrote actually works. All right, next up, we're going to create a game mode that will control the game. And we'll build a game mode that can actually spawn multiple enemies randomly throughout the game. So join me in our next section. We're going to learn how to dynamically spawn enemies with C++.